Hi, in this video I'm going to show you some stuff about the first hand rule. Now, the very first thing you should know about any of the hand rules is making sure that you're using the correct hand. And one thing that I'm going to be doing is I'm going to be facing towards you while I do a lot of this, but just always keep in mind that whenever I'm doing anything with electrons, negative charges, electron flow current, any of that sort of stuff, I'm going to have to be using my left hand. And anytime that I do anything involving alpha particles, positive charges, conventional current, if it comes up, I'm going to be doing my right hand. So left hand, everything that's negative, right hand, everything that's positive. And now I'm turned around like this too. The other thing that I would suggest when you're doing any of the hand rule stuff is have something you can physically grab onto, whether it's a water bottle or something kind of brick shaped like this battery or something, but something you can physically hold onto with your fingers. It's really going to help you visualize what's going on. And then also remember that if at any time while you're trying to do any of the hand rules, you feel like you're cracking your arm around to try to do it, just do something simple like turn the page or something like that, just to rotate the diagram instead of trying to break your own arm spinning it around in a whole bunch of different directions. So here's the idea then for the first hand rule. First hand rule basically says we have a current carrying length of wire and it's a straight piece of wire. So first hand rule, straight piece of wire. And we want to know stuff about the magnetic field that surrounds it, because as soon as electricity is going through that wire, there will be an external magnetic field induced around the wire. The other way of looking at it is I could tell you, I know this about the external field, and now tell me the direction of the current. So any of these rules, we can do them either which way. So let's start with sort of the most basic kind of diagram that I could do for you, where I tell you that that's my piece of wire, and we're just representing it as a line, and that I'm showing electron flow current going up through that wire. I'm using I as my symbol because it's the symbol for current in any of the formulas we do. I'm assuming it's electron flow current unless I'm told otherwise, because we're always supposed to assume electron flow current, because the closest model that we have that really kind of describes what's going on is electrons are moving in this wire. So here's what I got to basically do then. Using my left hand for electron flow current, my thumb shows the direction of the current and my fingers wrap around the wire in the direction of the magnetic field. Now that does mean that the magnetic field is pointing in different directions at different locations near the wire. Most of the time, we're only going to ask you about a few very specific spots. We're going to say, like, if we're on the left-hand side, if we're on the right-hand side, if we're in front of the wire, or even behind the wire, okay? So let's first look at what's happening if I'm here on the right-hand side of the wire. And I'm drawing a circle there because I'm supposed to kind of try to imagine I put a compass there. And it's a magical compass. It can point any direction we need it to, so don't worry about like whether the needle would tip over or something like that. It can point any direction that we need it to. So I'm going to use this as representing my wire just so I have something to easily grab hold of with my hand. I'm taking my left hand, and if I grabbed it like this, that would be very wrong, because my thumb is pointing the wrong direction. My thumb is pointing downwards. And everything we do in these hand rules assumes that you don't have to be like some double-jointed Cirque du Soleil person to try to grab this. You're just grabbing it normally with your hand. So what I'm going to do is I'm going to take my left hand and I'm going to grab it so that my thumb is pointing up in the direction of the current. Now, take a look at my fingertips on this side, because it really is on the side that I want to know what direction the magnetic field is. On the right-hand side of the wire, so on the right-hand side of whatever you're grabbing. Do you notice my fingertips, because it's the fingertips we're looking at, they're pointing out towards where you are. They're pointing out of the board. We need a symbol that can show that when we're doing these flat 2D diagrams, that something 3D is happening. So what we're supposed to imagine is like if an arrow was coming towards you, you would see the tip of the arrow coming out towards you. So we draw a dot, okay? Now if you really want to, you can also label this with a B to show that that's the magnetic field. Just to clarify that when we're doing diagrams, we should label things so that we know exactly what that's supposed to mean. The magnetic field on this side is coming out towards you. Now, what about if I was looking at what's happening on the opposite side? On the left-hand side, I've still got my thumb pointing up. I can't change that. But I can kind of rotate my fingers around like this. By the time I get my fingertips over onto this side over here, my fingertips are pointing away from you into the board. So how do we show that? Again, we're supposed to imagine like shooting arrows. And if you were shooting an arrow away from you, you would see the tail feathers on it. So we show an X. And again, if you want to label it as B for magnetic field, great. But what we're seeing is the magnetic field was coming out here and on the other side going into the board. Okay, so not too crazy that in one spot it's doing one thing and on the opposite side it's doing the opposite. Another thing I will mention is that if I had drawn this compass like down here, it would still be doing the same thing. And if I had drawn this compass like up here, it would still be doing the same thing, because even though I might have shifted them up and down a little bit, this one is still on that side and this one is still on this side. Now, how do we show a compass that we're trying to measure the magnetic field like in front of the wire? Well, we draw a circle again, but we would draw it like this. You'll notice I erased the line there, right? Because the idea is, if you had a wire and you put a compass in front of it, it blocks you from seeing the wire at that spot. So that's why we draw the circle, representing that we placed a compass there, but we get rid of the line to show that it's in front of the wire, okay? So I'll take this, I grab it, and I curl my fingers around. Notice my fingertips are in front of my wire now. My fingertips are pointing this way. So that means I need to draw an arrow that points that direction, pointing to the left basically. And again, this I could shift down to here or up to here. As long as I'm showing it in front of the wire, that all stays the same, okay? A compass that is behind the wire, we draw like that. And we actually leave the line in there, because now what we're trying to show is, if this is my wire, I put the compass behind it, you can see the wire in front of the compass, okay? So, take my hand, and I'm gonna have to keep on kind of spinning around like this. Now, you're not gonna see in a second when my fingertips disappear, but can you believe me that when I get to this side, my fingertips are now pointing that way, behind this battery that I'm holding on to as my wire, okay? My fingertips are pointing that way. So I draw an arrow that points that way. So the magnetic field is coming out on this side, it goes around in front like that, goes into the board on this side, and then behind when it goes behind the wire. It doesn't matter if I change the orientation of the wire. I could draw my wire like this and say the current is going that way. I still do all the same rules. So I'm gonna, again, use this battery I'm holding on to represent the wire. I have to hold it with my left hand. I'm holding it so that my thumb is pointing that way. And I could start asking you things like, what's happening above the wire? So as I'm holding it like this, with my thumb pointing that way for the direction of the current, and I start rolling my hand, by the time I get my fingertips on top, my fingertips are pointing out towards you, out of the board. Put a dot there to show that the magnetic field is coming out towards you. And then I just keep on going, answering for any spots that I'm being asked about. But what if, instead of showing you the direction of the current in the wire, what if we showed a magnetic field, and then I said, so what's the current in the wire? So I'm going to draw a wire like this, and I'm going to tell you that I've got a compass that I've put over here that is pointing, showing that the magnetic field is coming out towards you. And here's where I'm going to throw in a little bit of a twist. I'm going to tell you that I want to know the direction of the conventional current in the wire. Now what I could do is I could figure out for the electron flow current using my left hand, and then I just flip it because the conventional current is the opposite of the electron flow current. But what the heck, I'll use my right hand to do this one, because right hand will do positive conventional current, alpha particles, all that sort of stuff. So for this one, I basically look at it, if I'm holding my hand like this, my thumb pointing down, and I'm using my right hand, my fingertips on this side over here are pointing away from you into the board. That's wrong, because my fingertips are supposed to be pointing out. So I've got to take my whole hand and turn it, because now on this side over here, my fingertips are now pointing out towards you, out of the board. That means conventional current is pointing up. So I would show it as that. I for current, conventional, just to make sure that everybody sees I'm talking about conventional current in this case, because that's the special case for us when it's not electron flow. There's one other variation I can show you, because when people get used to doing these diagrams, too often they get hyper-focused on, hey, wires are always these straight lines drawn on the board sort of thing. Well, what if I showed this and I labeled it as I? So what that's supposed to kind of make you think of is, instead of holding a wire like this or something, we've turned it like this. So what you're now seeing is like the cross-section cutaway of that wire. And this wire shows that the current is coming out of the board towards you. So I could ask things like, well, what if I put a compass here or something like that? So I'm going to take my wire, this, and I'm going to hold it. I'm going back to electron flow current, so I'm using my left hand again, and I grab it so that instead of holding like my thumb this way or something like that, I have to hold it like this. Because the current is going out of the board towards you, my thumb has to point out towards you. And I look like, for example, above the wire, my fingertips, because my fingertips, as they rotate around, as I get above the wire, they're pointing this way. That shows that the magnetic field is looking like that. If I want to know what's happening on the left-hand side of the wire, I'm just going to kind of spin my hand back like this a little bit, and now I can see that my fingertips are pointing upwards. Now if I kept doing this, well, I'll make that look a little bit clearer for you. What I would find is that on this side it points down, and on this side points like that. See, what I've got is what ends up being this continuous clockwise loop around the wire. And that's really what it is. It doesn't have these specific spots where that's the only spot magnetic field is happening. the magnetic field exists all the way around this wire. Just usually we want to simplify the diagrams a little bit for you so that we're not asking too many things. But overall, the magnetic field does exist as a continuous loop around this wire. I hope that helps you out with the first hand rule. You got to practice it because it's really the only way that you're going to get good at this with any of the hand rule stuff. So make sure that you do try a few questions on your own. Thank you very much. Bye-bye.